Welcome and thank you for joining me in this lesson. We're going to take a look at a couple of examples where we have to find the vector equations of a line. So we're introduced to a couple of different situations here and we're going to discuss them together. Why not? So let's take a look at example 3. In example 3, we have to find the vector and parametric equation of a line that passes through this point, A14, and it has a direction vector m with coordinates -3 and 3. So whenever I answer a question, I focus on the question asked. So I have to find the vector equation, and I think, what do I know about the vector equation? Well, I know the formula of it. So I will write out the formula. xy equals x0, y0. This will be your starting vector. It plays the role of the initial point in a scalar equation, always remember that, plus some multiplier t, that multiplies the direction vector coordinates, which are indicated by A and B. So in order to write the equation, then we need to know what the coordinates of a starting vector are, so a point, and we need to know the coordinates of the direction vector. Direction vector is given right here. And what we're going to do is substitute right away and say that direction vector right here would be -3 and 3. So put it in brackets. The multiplier t will sit in here. Now we also need to know the coordinates of one point. And we are told that since the vector will pass at the point A, 1 and 4, then we can use the vector OA as the direction vector R0, where OA is a position vector with tail at 0, 0, 0, and head at 1, 4. So this would be 1 and 4. And voila, we got the equation of the line in vector form. So the next thing that we need to find is the parametric equation. So once you have your vector equation, parametric equation is a lot easier to determine. So all we have to do is write an equation for each x and y. So we are using the x coordinates, x equals 1 minus 3t, and then the y coordinates after. So y equals 4 plus 3t. And voila, we got both parametric equations in this case for this particular vector. Now we have to sketch the line and determine the coordinates of 4 other points on the line. And I will literally sketch the line in here. It would have been smart if I added a grid in here, but we'll survive. And I'm going to scale it. I will start off by writing the starting vector, so 1 and 4. So 1 and 4, here is x equals 1, and 1, 2, 3, 4. This is 4. So we'll say that the starting vector will be this one here. Now the direction vector is -3 and 3. So I will go -3 and +3. So that would be somewhere here. Here goes the direction vector, m. And this is our R0. So we'll say that the line must pass through R0 and must be parallel to vector m, because it must follow the direction of vector m. And here is the line. I will add an arrow at both ends of the line because the line never ends on both ends, right? At both ends. So next, our job would be to determine the coordinates of 4 points on the line. So remember that there is an infinite number of points on this line, which means that we can draw a vector r or a second vector r at any point on this line. So this can be a vector r, and this one here can be a vector r, and this one here can be a vector r, and so on and so forth. What all these vector r's will have in common is that they are written as the sum of vector r0 with coordinates x0, y0, and this vector here, which when you think about it, is always going to be parallel to direction vector, which means that it will always be a scalar multiple of the direction vector. So it can be this vector, but if we chose r to be, for example, right here, then it will be r0 plus, this will be this vector right here will be the scalar multiple of the vector m, the direction vector m. So if we want to find additional points on the line, then all we have to do is substitute different t values. So why is that? So if you decide to draw the vector r in here, or in here, or in here, now all these vectors will be written as a sum of r0 plus a scalar multiple of vector m. So if the vector r is here, then it will be written as a sum of r0 with a scalar multiple of vector m. So all these vectors, so any vector r is written or can be described as the sum, because the formula suggests the same thing, and that's where we got the formula from, right? Is described as the sum of vector r0 with a scalar multiple of vector m. Now, these two do not change. So what keeps changing when we change the vector r, or the location of vector r, is the value of t. So if you want to find additional points on the line, then you have to pick different values of t. So if t equals 1, then we'll say that x and y will be at 1, 4 plus 1, negative 3, comma 3. So that will make it 1 plus negative 3 for x. And then for y, we'll have 4 plus 3. So xy will be at negative 2, positive 7. So remember that to find the x and the y coordinates, we can use the parametric equation. So x equals 1 plus 1 times negative 3. That's where you get negative 2 from. Or and y equals 4 plus 1 times 3. So 4 plus 3, so that gives 7. So we're going to pick another value of t. We're not going to go as far as 4 points because they're found in the same way. So let's pick a more interesting t value. So let's say negative 5. So xy would equal 1, 4. And this time we'll have negative 5 multiplying negative 3, 3. So we're going to say that for the x coordinate, we are working with the x values. And for y coordinate, we're working with the y values of the starting vector and direction. So x and y then would equal 1 plus negative 5 times negative 3. So that will make x. And for y value, we'll have 4 plus negative 5 times 3. Obviously, these calculations can be done a lot faster. I'm just showing all the steps in here. So in other words, we'll say that 1 plus negative 5, negative 3, that will give us 17. And 4, negative 5, 3, that will give a negative 11. And another point on this line will be 17 and negative 11. Now next we're asked whether the point Q with the indicated coordinates or the point R are on the line. So for a point to be on a line, then the coordinates of the point must satisfy the equation. That was true for scalar equations. It is true for vector equations as well. So I'm going to start off by writing the equation, the vector equation of the line xy equals 1, 4 plus t negative 3, comma 3. So we're going to start off with point Q, which has the coordinates negative 21, comma 23. So for point Q to be on this line, it means that the x and the y coordinate of Q must satisfy the equation 1, 4 plus t negative 3, 3. So what that means is that the same t value must satisfy both x and the y coordinates. In other words, negative 21 equals 1 minus 3t, and Notice that here we are using the x coordinates or the parametric equation for x. And 23 equals 4 plus 3t. So that's a parametric equation for y. Right? So they must generate the same value of t because this point fits in this same equation. So let's check and see what happens here. So we have negative 22 equals negative 3t, from where we get the value of t equal to 22 divided by 3. If we look at the other parametric equation, we have 23 minus 4, that's 19 equals 3t, which gives the t value 19 over 3. So as you can see, these t values are different. So therefore, we're going to say that Q is not on the line. Let's check and see what happens with point R. So again, we're using the exact same equation, obviously. This time we are testing it for the point Q. So the coordinates of Q are negative 29 and 34. So negative 29, 34 must satisfy the equation 1, 4 plus t, negative 3, comma 3. Let's create the parametric equation. So for x and for y. So we're going to say that negative 29 equals 1 minus 3t. And 34 must equal 4 plus 3t. So the first and then the second parametric equation. So we need to make sure that both equations generate the same t value. So we get the same value there. So we have negative 30 equals negative 3t. It seems that the t value is happy to be 10 here. So the other one is 34 minus 4. That's 30 equals 3t. So it seems that this t value is also happy to be equal to 10. And that tells us that the t values agreeing means that x and y, negative 29 and 34, fit in this equation perfectly. So we're going to say congratulations. It seems that point Q is on the line. Okay, so we have the next example, and I'm going to create another video for this one. So see you soon. Bye for now.